Hello, Ace Trig students. Mr. Meunier again. Looking at your 8.3 Law of Cosine notes. Today, all I really wanted to do was the application problem at the end and assign a few problems covering that. So let's take a look at that. A motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away, maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents. The crew finds after 4 hours, the sailboat is off course by 20 degrees. And there's three parts of this problem. Part A, how far is the sailboat from Key West at this time? So we really need an accurate picture to see what's going on here. We have a boat leaving Naples, Florida, label that with an N maybe, and heading to Key West, label that with a K. The distance between those two cities is 150 miles. This boat travels 20 degrees off course. So we're in a 20-degree angle off course. For 4 hours traveling 15 miles per hour. So if we travel 15 miles an hour for 4 hours, we're moving 60 miles. We want to know how far are we now. I'll label our boat now with a B maybe, from Key West. So we can complete our triangle. We have a 20-degree angle in, 150 distance from N to K, and a 60-mile distance from N to B. We want to know how far is B to K. I'm going to label these sides lowercase n, opposite of angle n, lowercase k, opposite of angle K, and lowercase b, opposite of angle B. I cannot use law of sine. This is not, first, it's not a right triangle, so I cannot do Pythagorean theorem or SOHCAHTOA. I cannot use law of sines because I do not know an angle and an opposite side. I don't have to use the law of cosines. We're going to set this up to figure out side n, where n squared would then equal b squared plus k squared minus 2bk cosine of angle n. If we plug our values in, we get n squared equal to 150 squared plus 60 squared minus 2 times 150 times 60 times the cosine of 20 degrees. We clearly need a calculator to do this. So I'm going to pull my calculator up. Escape out of that. I'm going to put my calculator in degree mode, and I'm going to type in 150 squared, 50 squared plus 60 squared minus 2 times 150 times 60 times the cosine of 20 degrees. That's going to give us the n squared distance. I'm going to turn this into a decimal for us. I want to take the square root of that to figure out n. So the square root of my answer gives us a distance of approximately 95.8 miles. N equals 95.8 miles. So that tells us side N. Part B, through what angle should the sailboat turn to correct its course? So our sailboat is moving along the green dashed line I just put in. We want to turn to get back to Key West. I can figure that out by figuring out angle B of this triangle. Looking at angle B, it would be the largest angle in the triangle because it's opposite the largest side of 150. Therefore, it could be obtuse. I would want to avoid the law of sines to using that, and we're going to go to law of cosines. So for part B, I'm going to find angle B. I'm going to use the law of cosines. I'm going to set that up with b squared equal to k squared plus n squared minus, get this to work, minus 2 times k times n times the cosine of angle B, where I know B is 150 squared equal to k 60 squared plus n 95.8 squared minus 2 times k, which is 60, times n 95.8 times the cosine of angle B. As you manipulate through this, we will get, pull my calculator up, 150 squared is 22,500 equal to 60 squared plus 95.8 squared uh, 777.6 minus 2 times 60 times 95.8, 2 times 60 times 95.8, it's 11,496. Cosine of B. As I subtract over 22,500 minus 1277.6, we're going to get 9722.4 equal to negative 11,496 cosine of B. Move that over, 9722.4 over negative 11,496 is the cosine of B. And we can take the inverse of that to get our angle B. So the inverse cosine of 9722.4 divided by negative 11,496 gives us an angle of 147.7 degrees. So if you look at our picture, angle B is 147.7 degrees, but that is not quite the angle in which we're turning in. We're turning through the green angle I have listed in the picture here. Now this is a straight line going through point B. All straight lines sum to be 180. If the chunk I am circling is 147.7, the missing chunk, our turn angle, would be 180, take away 147.7, which means we're going to turn through an angle of 32.3 degrees. So in part B, we're turning a 32.3 degree angle. All right. Then part C, how much time has been added to the trip because of this? Assume the speed remains at 15 miles per hour. I'm going to clear this out to get space back on my screen. So again, here we go. And we have a triangle. Try to get us reconfigured here. No. N, K, B for boat. We had 147.7, 20, 150, 60, and 95.8. How much time has been added to the trip because of this? Well, our trip is going to be 60 miles we traveled off course plus 95.8 miles to get back to Key West is going to give us, oopsie. Let me add those two numbers together. 60 plus 95.8, 155.8 mile trip. We were originally supposed to do 150 miles. So we will travel an extra 155.8, take away 150, excuse me, 155.8, take away 150. We're going to travel an extra 5.8 miles. And if I'm going to do this at 15 miles per hour, we can take our 5.8 miles divided by 15 miles per hour. If we divide those two values, we're going to have 5.8 divided by 15 gives us an extra 0.386 hours. Or I can multiply that by 60 and figure out how many minutes we've added on. About approximately 23.2 minutes. Has been added to this trip. All right, all. I hope that made a little bit of sense. Please look through this, copy this into your notes, your assignment today. I would love it if you guys attempted page 538, number 43 to 45, 43, 44, and 45. All righty, signing off.